Hello viewers, welcome to my channel KK Concepts of Electrical Engineering.
Wave propagation in good dielectric medium. A good dielectric medium can be considered as low loss medium since there is some power loss during the wave propagation. Let us try to obtain the expressions for gamma, alpha, beta and V for such lossy medium. Now consider the expression for propagation constant gamma equals to square root of j omega mu of sigma plus j omega epsilon. Now, square root of j omega mu, taking j omega epsilon out of this, then you are going to get 1 plus sigma by j omega epsilon. Then you have j square and omega square. I'm taking j omega out. Then square root of mu epsilon, square root of 1 minus j sigma by omega epsilon. 1 by j equals to minus j. This is our gamma. So when you observe this term, 1 minus j sigma omega epsilon whole to the power of 1 by 2. This is in the form that 1 minus x whole to the power of n. Then try to expand that. 1 minus x whole to the power of n equals to 1 minus nx plus n into n minus 1 divided by 1 into 2 x square minus n into n minus 1 n minus 2 of x cube divided by 1 into 2 into 3 and so on. So neglecting the higher powers, 1 minus j sigma omega epsilon whole to the power of 1 by 2 equals to 1 minus n is half. So x is j sigma omega epsilon plus half minus 1 into x square. X is j square sigma omega epsilon on whole square divided by 1 into 2. Now let's find out this value. 1 minus j sigma 2 omega epsilon plus 8 sigma square divided by omega square epsilon square. Now let us substitute this value in the original equation. Then gamma equals to j omega square root of omega epsilon multiplied by 1 minus j sigma 2 omega epsilon plus sigma square divided by 8 omega square epsilon square. So let us multiply this term and this term, then you are going to get j square is minus 1, so minus of minus plus. So you will be getting sigma 2 omega epsilon multiplied by omega square root of mu epsilon plus j omega square root of mu epsilon, and the third term is j omega square root of mu epsilon sigma square divided by 8 omega square epsilon square. You are going to get omega gets cancelled, square root of mu epsilon sigma by 2 epsilon plus j omega mu epsilon under the square root multiplied by 1 plus 1 by 8 of sigma square divided by omega square epsilon square. Now this is what we got as gamma equals to. Now compare this with relation, this gamma equals to alpha plus j beta, where alpha is the attenuation constant, that is real part, and beta is phase constant, that is imaginary part. So this is our imaginary part. So alpha equals to square root of mu epsilon multiplied by sigma 2 epsilon. Then we can write this sigma by 2 square root of mu by epsilon, and beta equals to omega square root of mu epsilon 1 plus 1 by 8 sigma square divided by omega square epsilon square. For perfect dielectric, that is conductivity sigma equals to 0, this formula alpha equals to 0 and beta equals to, second term is 0. So first term remains omega square root of mu epsilon. For lossy medium, sigma has a low value and hence attenuation is quite small. Then propagation velocity v equals to omega by beta. These values will get v equals to omega divided by omega square root of mu epsilon of 1 plus 1 by 8 sigma square omega square epsilon square. Let's cancel. Then you are going to get 1 by square root of mu epsilon 1 minus 1 by 8 sigma square omega square epsilon square. For a perfect dielectric, propagation velocity V naught equals to, that is omega divided by beta. So omega divided by omega into this, then 1 by mu epsilon square root of. V naught is nothing but velocity of propagation in perfect dielectric, which is also velocity of propagation in free space. Now this equation is going to change as V is approximately equals to, this is V naught and 1 minus 1 by 8 sigma square by omega square epsilon square. For perfect dielectric, these are alpha, beta and V naught values. For lossy medium, that is good dielectric, these are alpha, beta and V values, and these are gamma value. Further, we can simplify the velocity of propagation in lossy medium, that is V equals to V naught 1 minus 1 by 8 sigma by omega epsilon whole square. So in this expression, that sigma divided by omega epsilon is nothing but the ratio of conduction current density J and displacement current density JD. When the pure capacitor is there, then this voltage V, the current in the capacitor IC, in a pure capacitor, the current IC leads the voltage V by exact 90 degrees and there is no loss of power. But in dielectric, in which there is a power loss, the current IC leads the voltage by an angle less than 90 degrees. This is our IC dash for good dielectric. Now let that is the angle between these two, IC and IC dash. Now tan theta is termed as loss tangent, and this can be shown that tan theta equals to sigma by omega epsilon, which is nothing but conduction current density divided by the displacement current density JD. For a perfect dielectric, theta equals to 0, sigma equals to 0, and smaller the angle theta, lower the power losses. Theta is less, then power losses will be less. Hence, the loss tangent, which is nothing but tan theta or sigma by omega epsilon, plays an important role in wave propagation. For lossy medium, sigma divided by omega epsilon less than 1.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.